welcome. So this is going to be the first of a two-part series on systems engineering as a career. I'm joined here with three engineers from Shoal, and they're going to be answering a few questions on what it's like to have a career in systems engineering and a few other questions about project management and all that fun stuff. So this is part of Aerospace Futures Online. I'm Hannah from the Australian Youth Aerospace Association. We have been putting together a bunch of online videos and content to replace our physical event that had to unfortunately be cancelled this year. So this first part is going to be a bit on what systems engineering is and what it looks like as a career. And in 2 weeks' time, we will have another part on how systems engineering can lead to better project outcomes. So I suppose we'll start by having everyone introduce themselves and tell us a little bit about who you are, what you do, and what made you pursue a career in systems engineering. So Matt, do you want to start off?
Absolutely. So my name's Matt. I've been with Shoal for about 1.5 years now as a full-time. I'm with the decision support analytics team. So as far as the career in systems engineering, that I guess wasn't super intentional. I first heard about Shoal at Aerospace Futures, I think in 2016, and applied for an internship and got that. And that's really where I learnt what systems engineering was. So 2 internships later, here in a full-time role.
My name is Sheena Howell. I've been with Shoal for about 8 months now, and, but in industry a little bit longer than that. I sort of also fell into systems engineering, so my degree is in mechanical engineering with a minor in aerospace, and started in an aerospace company as a quality engineer, which is sort of the other end of the system engineering V of systems engineering. But a good introduction to understanding how everything connects together and doing that verification and validation part of the engineering V. And have worked multiple roles since then and found myself at Shoal, and now I am the space program lead for space systems engineering.
Hi everybody, Kevin Robinson. I'm the Chief Engineer and Head of Blue Water, which is our innovation program here at Shoal. I've been here for about 2.5 years. And I guess my role in the company is to make sure that all our systems engineers are working together and producing good outcomes for our clients. And from our Blue Water perspective, bringing novel, forward-leaning, leading-edge kind of systems engineering capabilities into the marketplace is one of my responsibilities there. And I think you did ask why we got into systems engineering, did you?
Yeah.
Shall I answer that one for you? I guess one of the driving factors for me for getting into systems engineering was I just love the ability to learn. And what I mean by that is when you're on a project, you have to understand all the connected components and the different technologies. And coming from a particular discipline background that I did, having the ability to learn about other disciplines is a really exciting opportunity, and bringing together a large, more complex system. So that's one of the reasons I got into systems engineering.
That's awesome. Yeah. I suppose because you're all at different points in your career. From your experience and in your own words, what is systems engineering and how does it actually differ from other specific engineering fields like aerospace or mechanical?
Why did you all look at me? I guess for me, systems engineering, I think in those particular disciplines, and I think you have another question later because I did read the questions, engineering brings together a system. I guess systems engineering for me is required when the system you're bringing together requires different disciplines. So it requires someone with an RF, a radio frequency background, or it requires someone with a chemical background, or a mechanical background, or aerospace. And when you have systems like that, such as a space rocket, for example, you need some sort of systems engineering to bring all those people together and bring it together as a holistic outcome, and I guess that's where I see systems engineering fitting in, and what its role is to deliver that system, and bridging across all those disciplines in a simple way, maybe.
Yep, I think to build on that, when you're talking mechanical engineering or aerospace engineering, they're very specific to what they're trying to design. So you're trying to optimize the engine or the thrust. And so there's a classic cartoon about what an airplane looks like to a structural engineer versus an aerodynamicist versus, and taking, systems engineering is about kind of stepping back and looking holistically at the broader context of things. So how do you optimize across all of the different things? How do you make sure that everything fits together? And I think there's some talk about risk management. It's about identifying interfaces and areas where risk can occur, because it's usually at the places where things meet together, and making sure that you understand the system as a whole so that you can then dive down and individually develop in those units, specific disciplines, yeah.
I guess just to add to all of that, I think there's also an element of, I guess in my experience, a lot of understanding what the system actually is actually trying to do. So understanding the stakeholder needs and making sure that at the start you're defining your system right, you're specifying it correctly, and then at the very end making sure that you're actually showing that you've satisfied their needs and actually understood their needs correctly.
Is that what you thought? I mean, you're only 1 year in. Is that what you thought it was in uni?
No, I don't think I really had a good idea of what I thought it was in uni. I think I learned sort of that very quickly in my first project here at Shoal.
Yeah, so it's a bit difficult because I mean I found speaking to a lot of people about systems engineering, there's a lot of confusion about systems engineering versus like project management. I think that they sort of unfairly get lumped into the same thing, and it would be really good to just differentiate the two. So I mean, Sheena, you sort of might know a little bit about, we were sort of talking about it earlier, what the difference is.
Yeah, so I think when you're talking about project management, your focus is on delivering within a cost, a schedule, a budget, and to a customer satisfaction. That is your focus. Yeah. So you're focused on the money, the time, the resources, whereas systems engineering is all about the actual thing that you're designing. I think there's very clear, there's a bit of overlap in terms of that you're looking to define an entire system and understand the complexity of it and deliver a system, but very, very different focuses in terms of systems engineering is about, like you said, understanding the stakeholder needs so that you can properly define the system that they want to get to and then detailing that out and delivering that, whereas project management is more about the actual how much money is it going to cost me, how many resources, who do I need to have where, doing what, when, and then managing that type of risk, not technical risk.
Okay, yeah.
In my perspective.
I can't add more to that. There's an overlap, as you indicate, and it's just the different focus. And both the systems engineer and a project manager will have to work together to deliver a project. So, I kind of forward that.
Yeah, and what's the difference between systems engineering and like good engineering? Because I feel like, understanding the stakeholder needs, everyone should be at least a little bit around that. So, is there a difference, really? I tried to answer a little bit earlier on, and maybe then I'll hand over to Matt. But for me, as I said, good engineering is a good term. I guess the difference for me going from good engineering to good systems engineering is when you have those different disciplines that you're trying to interface, because the risks are at the interface. If you think, if you're a communications engineer, you could very easily design through good engineering a communications network and have a good outcome. It's when you have to mix that technology with other different technologies is when you need a systems engineer that can work across those different disciplines. So yeah, Matt, did you want to?
I think system engineering can also, it's a discipline. There's definitions and processes for how you do things. I think it adds a bit more structure to good engineering, perhaps. As far as there's certainly plenty of resources and different tools that systems engineers use to achieve good results.
Yeah. And following on what I said earlier, you can be a good mechanical engineer or aerospace engineer, but if you're only optimizing that system, you do really well at optimizing that system, but if the systems engineer is about connecting that, like Kevin said, to the other systems and making sure it works across the board.
That makes sense, yeah. I suppose, I've sort of understood a little bit about what exactly systems engineering is. Really great to just find out about something cool that you've worked on or are currently working on, and how systems engineering sort of played into that a little bit. So, yeah, Matt, do you want to
Sure thing.
start off?
I think my very first project at Shoal was a pretty good example of that. So I was working for an electronics company in Adelaide, and we were tasked with building this product and having a prototype ready very quickly. So that was, certainly a crash course in systems engineering for me, but I was working very closely with the project manager and really having to interact with a lot of the stakeholders to work out, well, what does this thing actually need to do? How can we give best value? How can we sell this? And then feeding that down to the electronics, to the mechanical, and to the software teams, writing the system specification and all of that. So that was certainly a very exciting project. I sort of got to see this product from the very start, from when it was just an idea, right through to developing that prototype and doing the testing and evaluation on that.
I think for me right now, it's working with the SmartSat CRC. Shoal was selected as part of a team of people working on a project called CHORUS, which stands for Compact Hybrid Optical and RF User Segment, which is trying to define a compact mobile satellite communications terminal that's both optical and RF, and it's determining the feasibility of that in this first phase. And we're able to kind of be the bridge between all of the different systems experts. So we've got optical experts and RF experts, but they've not really worked together, and they even speak different languages. So we get to be the bridge that gaps those two and help them define what the system might look like going forward and doing the feasibility. It's really awesome. Really cool work.
Maybe I'll go back to, it's not a Shoal project, but one I did after leaving university. I worked on the UK's ASRAAM missile, which is Advanced Short Range Air-to-Air Missile. And my first role on that was to get really engaged in the modelling, simulation and analysis. And modelling, executable analytical modelling is a great tool to help a systems engineer out. And I learned a tremendous amount during those early years, where I really had to get to understand the system itself and all the different technologies involved in there, from the rocket motor through to the seeker, the guidance, the aerodynamics, and all those kind of different technologies, but all in a modelling environment. And that particular model had a lot of the control algorithms in the loop in the model. And so it was very exciting to actually go through that process of discovering and learning about the system, and then getting to the point where actually can help design the system and advance the system and the algorithms controlling that. So it was and then 10 years after that, I saw the thing fly, which was very exciting. So it was really good. So that was a great systems engineering role for me to get into.
Yeah, it's interesting just how diverse all of the projects are. Like, it's nice. Yeah. It fits into everyone's cup of tea.
Well, Shoal does everything from transport to defense to space. So, even just at Shoal, and medical, we've got a very broad range of projects. It's very cool to be able to do so many different types of activities.
Yeah, I suppose leading on from that, obviously, Shoal does so many different things. Do you ever have to consult in areas outside of your trained specialization? Okay, how do you deal with that? Because not everyone knows everything.
I guess our specialisation is systems engineering, so we don't really consult outside of that. But in terms of, if you go around the office here or Canberra or Melbourne, wherever it is, what you'll find is every individual has a different discipline as a background. And whether it's, someone's come up to the chemical engineering discipline or communications, or for me it was control systems design, whatever it is, we've all got that specialisation where we've got some deep expertise in that particular area. But what brings us all together is that systems thinking, which that we then bring into our discipline, which is systems engineering. So I guess we're always being challenged when you actually have to go and talk. For me, if I had to talk to a chemical engineer, I would struggle for the first week, but once you you start to understand it, and as Sheen talked about, start to understanding their interfaces into the rest of the system. That's what you're really trying to do. It becomes quite exciting and a great learning opportunity. So.
Well, and I was going to say that I think sometimes being a little bit a beginner's mind, let's say, I was going to say ignorant, but let's say we start with a beginner's mind when you come into a project is really helpful, because you are trying to elicit from a customer, a client at some point, what their needs are, and they don't necessarily speak the jargon of, like if you're asking a defense customer, they don't necessarily speak in aerospace terms, right? So if we can just come in and ask questions and probe and get good information about, well, what is it you're trying to do? What is it you want to achieve out of this capability? Then we can go, okay, now let's go talk to the subject matter experts and see how we can fit these things together. So it's about always asking good questions, and not knowing sometimes can be an advantage. Now, I think each project, I think one of the things that drives systems engineers, and Kevin brought this up, was that desire for learning, because you get to learn something new every time, every project. And so taking that as like just part of what you get to do as an opportunity, yeah, then starting with the beginner's mind, learning, and then connecting the dots, that's what we get to do.
Sounds like we just have to get used to not knowing everything before we start, and getting used to learning on the spot, almost. Do you have any tips for how to, like, it can be quite daunting walking into a project where you just don't have that background knowledge. Do you have any tips for quickly learning at least a little bit of how to communicate? Like, you might have a bit of insight.
Yeah, so I mean, I think as always the biggest thing is just ask questions. Ask lots of questions. Don't be afraid. Don't.
Curiosity.
Yeah, exactly. People aren't going to expect you to know everything about whatever their specialization is, especially as a systems engineer, and especially early on in your career. So yeah, ask questions.
Yeah, I think that's the key, is don't pretend like you know more than you do. It's just come in and say, look, I am an expert at this. I don't know your technology in detail, but I'm going to help you by doing these things. So let's grow together. And I think people are really typically open to that, to say, okay, excellent, I'll teach you what you need to know so that we can come together on this project. Because it's all about delivering a solution, right? To delivering something for the customer. So, people are usually pretty open about helping you on that journey.
And I would just add, I guess one thing that systems engineering does well is employ frameworks to help you think through the kind of questions you need to be asking. And I guess as an organisation, Shoal, that's what we sort of base a lot of our approaches to these projects on, is defining that structure, that framework back to help the thinking, to help elicit those right questions, as well as our own individual experiences as well. So sort of bringing those two together really sort of adds value to a project to really get that curiosity and ask the right questions at the right time.
And I'd have to say that here at Shoal, at least, we have such a strong network of people we work with, and there's no like boundaries or barriers to asking questions internal to the company. So I can go to Kevin, who's our chief engineer and has lots of experience in control systems, and be like, can you help me with this? Or, we've got so many people from different backgrounds that you can always leverage that as well, which is really nice.
It's always good to be able to help each other out. Yeah. So I suppose a little bit different, but what is model-based engineering, and how does that play into? I don't know. You were mentioning modeling before.
Yeah.
Modeling. Everyone's
I guess what is it? And there's many different angles to it. And I guess the right term at the moment that's getting used more and more is digital engineering. So, and what they mean by model-based or digital engineering, really we just call it systems engineering, because that's the actual discipline. The model-based is brought into because I guess these days we have more and more opportunities in our digital world to build models of the things that are important to designing a system. And whether that's right up front from what we would call a descriptive model of the stakeholder needs, like Matt mentioned, or the system requirements and how they relate to the system functions, and they relate to what the thing you're designing is trying to achieve in an operational context, through to CAD drawings. If you can connect all those together, you have one sort of you have one, in a modelling world, let's say, you have one source of information Whereas I guess in the current context, what happens is, you know, an agency will write a specification in a Word document and hand that over to someone to build it, and then they write a bunch of other documents and they put that in a different tool, and all of a sudden you've got 3 forms of the same information, and that's where errors start to creep in. You've got air gaps, you might forget things. Also, text documents is basically unstructured information, and it's very narrative written, whereas if you go into a model, you have to be more formal. So I guess for me it's around moving it to more a structured approach and leveraging the tools that are out there at the moment, from mathematical models to CAD models to descriptive models, and bringing them all into one repository. So maybe Sheena or Matt want to add to that? You can say no.
I think yeah, model-based systems engineering is an approach, like Kevin said, it brings a rigor. You can do it outside of any sort of digital tool, as long as you follow that same framework or architecture. However, bringing things into a digital environment allows you to easily accumulate and relate information, because you're talking about complex systems. So you have a stakeholder might perform multiple tasks exchange information, you have parameters and constraints and needs that all fit onto that same thing. So it's about looking at all of the layers of information in the same place, rather than having this document and that document, a strategy document, and then a policy, and then a procedure, and then a work instruction, and then, like you said, those start to as they get updated, drift further and further away from each other. If you can see all of that connected, and so you understand, oh, if I tweak this you know, motor specification down at this level, oh, that actually impacts all the way up to my user strategy design, and seeing that thread of information together and understanding how it impacts up the stream and down the stream as you go into like using, how does it impact the end product, how does it impact the original need, and having that all in one place. That's the value of having digital engineering.
Yeah. That explains it quite well, actually. Yeah, I definitely now sort of have a bit of a better understanding. Hopefully, audience definitely, hopefully do. I suppose we'll sort of wrap it up here for the first part. We've got another part coming out in 2 weeks' time. That one is going to be focused on systems and how systems engineering can lead to better project outcomes. So thank you for listening, and hopefully see you in 2 weeks.